Hi, I'm Adam. Welcome back to Godot Gamedev. In this video, we'll take a look at the Velocity Movement 2D component. Now, designing components can be as easy as asking three important questions. What is that one thing that the component does? What data is needed for the component to do its thing? And finally, how does it communicate with other components and the outside world in general? Now, what is that one thing that the Velocity Movement 2D component does? It moves any 2D node based on a velocity vector. This can be used for both linear style of movement, like for example for bullets or lasers, but also for parabolic arcs, like grenades and arrows with applied y-axis gravity. So again, the main use case for this component is to move something towards a constant direction with a velocity. Now, what data does this Velocity Movement 2D component need? First of all, it needs a target node 2D that it wants to move. Then it also needs a given speed constant in pixels per second, an optional gravity value. 0 means that this will be linear movement with no y-axis velocity applied. Anything bigger than 0 means that there will be an arc to the movement. And finally, we provide a Boolean flag for when we apply the gravity, we sometimes want the target node 2D to rotate as well based on the direction of the velocity vector. For example, in the case of arrows, like you've seen it with the example. Now, how do they communicate with the outside world, the Velocity Movement 2D components? Well, they don't really have to. No outside communication is needed in this case because they directly move the target node 2D in the physics process virtual method. Still, sometimes you might want to have communication. For example, if you use arrows, you might want to delete them if they leave the screen, or you might want to be notified when they hit some sort of a target, for example, a wall or an enemy unit. But this should not be handled by this component directly because it is only responsible for one thing, which is moving the node itself. For these two examples, if you want it to be notified when it leaves the screen, just use a visible on-screen notifier 2D next to this component, right? Or if you want to be notified when it hits some sort of a target, just make sure that the target itself is an area 2D, which can send the signals when an area enters or exits the arrow. For strictly this component, there is no need for any communication. With that out of the way, let's move on to the implementation part. First of all, this component shows a node configuration warning when there's no valid target set. For this to work, the script needs to run inside the editor, hence the tool annotation at the top. Next, we provide a custom icon which makes the component feel like it's part of the Godot ecosystem when you add it to the scene tree. A quick little side note and shout out here. VoxyBuns have this awesome 400 vector SVG icon pack for the Godot editor with all the official colors, like red for the 3D nodes, green for the control nodes, and blue for the 2D nodes. And finally white, or this grayish color, for the general nodes. And it's awesome. It provides basically 400 icons in each color variation. And I just wanted this little shout out and also tell you about this. It's super useful if you want to use your own editor icons for your projects. And it saves me a ton of time because I'm not that good in art. And I also spend a lot of time on designing these custom icons for the component course. But now I can just use this awesome pack. So again, thanks for VoxyBuns. Link will be in the description if you're interested. So back to the code. After providing the custom icon, we provide the custom class name, and we extend the Velocity Movement 2D component from the node class, not from node 2D, because we have a different target reference which we want to move, and that will be a node 2D, but this node itself needs no coordinates or anything like that. Next, we define an export variable for the target, which is a node 2D, and provide a custom setter function. This is only needed so it can call update configuration warnings, so a warning message can be displayed if there's no target set for this component. Then we have a bunch of other export variables, one float for the speed, one float for the gravity. Again, if it's 0.0, it means that it's a linear movement with no arcs applied. And finally, we have the bool flag, which is called rotate based on velocity. It defaults to false because if we want to use it for a linear movement, we don't really want to rotate the target every frame. We just want to rotate it once when we launch it. Then we have a so-called private member variable, hence the leading underscore for the current velocity, which is a vector 2. Then we do some stuff inside the ready function. First of all, if there's no target set in the inspector, we default it to the parent node of the Velocity Movement 2D, because most of the time you want to attach this component to a parent that you want to move, To make things simpler, you don't even have to set it. If it's the parent, the component will do it for you. And afterwards, we set an initial velocity based on the target's current global rotation. So we take the right vector because most sprites, when they are not rotated 0 degrees, means that the sprite or the node is looking towards the right. So we take the right unit vector and rotate it with the global rotation of the target and multiply it by the speed. So the velocity vector becomes longer, so to speak, the arrow becomes longer based on the current speed. So this means that before we even start to move the target based on this velocity, we sort of just rotate it towards the current global rotation of the target and set the speed. So we sort of set a starting value for the velocity, so it's not just an unset vector too. We say that the movement should start towards that way with the speed that we have. Then we override the getConfigurationWarnings method. Here we have two cases to handle. If the target is not set, or if it's set but it's not a node 2D, we display a warning message that there's no valid target set for the velocity movement 2D component. Otherwise, if everything's fine, we return an empty array, meaning that there are no warnings. And finally, we need to handle the movement inside physics process. So first of all, we have a safeguard. If there is no valid target set, we check it with isInstanceValid. This is useful because it doesn't just check for null values, but also if it's being deleted or something like that, we don't want to move anything that is being deleted, right? So if this isInstanceValid returns false, or we are inside the editor, we need to check that as well because we have the tool annotation, if you remember, for the warnings. So if we are not in game or we don't have a valid target, we can return from the method early. But then if we do have, we need to do multiple things. First of all, if we have a positive gravity, we need to apply that gravity with an acceleration pattern for the velocity. So we don't just override the y velocity with an assignment, but we use plus equals because gravity is sort of like an accelerated movement, right? So it accumulates over time. So we just add to the y velocity the gravity multiplied by delta to make it frame rate independent. But we only need to do this if we do have some gravity that we want to apply. Then, regardless of the gravity, we need to translate the target, which means moving it along its own axis. So we add to the global position of the target based on the current velocity multiplied by delta. And finally, if we enable the rotate based on velocity flag for arrows, for example, that do have gravity applied, then we want to rotate the target based on the angle of the velocity. So we set the target's rotation value based on the current velocity's angle. And that's really all about implementation. Let's see how we can use it in an example. If you like my content, please consider checking out my Ko-fi page where you can donate one time or become a member and get early access to all my content and videos. So with the project open, I have this velocity movement 2D scene open. Let's take a look at the scene setup first. We have a character that has a weapon, no 2D attached to it, and this weapon is anchored towards the center of the character, and it has two hand sprites, a bow sprite, and the muzzle for aiming the bow and spawning the arrows from this point. The weapon no 2D is useful because if we rotate this weapon, you see that the point of rotation will be this pivot point, so it looks like we are aiming with our hands. And we want to spawn the arrows from the muzzle, but one important side note with spawning, if you've seen the scene spawner video, is that we want to spawn the arrow at this position with the rotation that it inherits from the parent, but also we don't want to spawn it under the muzzle, because that would mean that if I spawn an arrow, let me show you. So if we add the velocity to the arrow here. This is a child for the muzzle, right? So based on the code, the arrow will start to move towards this direction. But the problem is, as it starts to move, it's still connected to this ecosystem, right? So if I then use the mouse to aim the bow, the arrow itself is dependent on the rotation of the parent. So this way, if I keep aiming with the mouse, the arrow will update its rotation as well. And we don't really want to do that. What we want to do instead is something that we tackled with the scene spawner to spawn it top level, which means that yes, we want to spawn it at the position of the muzzle with the rotation applied as well, but we also want to make it independent from the parent. So if I start to move it along this direction, it's no longer connected to the weapon part of the scene tree. So if I were to rotate this, it will be independent from the arrow. And that's exactly what we want here, right? But we'll do that from code. So for now, it's enough that we have this setup here, and we also have some GUI elements, but that's not that important. We just have a toggle with which we can set the y velocity gravity if we want to test this. Now we do have one script attached to the parent node. So let's take a look at the code. It's pretty straightforward as well. We have an export variable for the arrow scene that we want to spawn, and we handled two input events. One is when we press the fire button, and one is when we move the mouse. So moving the mouse is the easier one. Let's start with that. What we want to do is update the weapon. Remember this node that we rotated in the inspector as well. We want to update its rotation based on the global mouse position, and we have that look at method to do this. If you take a look at it, it rotates the node so the local plus x axis points towards the point, which is expected to use global coordinates. This is super useful because then we can just pass in the global mouse position, and it's like it looks at the global mouse position's coordinate. So that way, when we run the scene, you can see that as I move the mouse around, the weapon will always look at it directly and update its rotation. It's an easy way to do this aiming. Now the more important one is when we press the fire button to spawn arrows. So first of all, we instantiate the arrow scene. Again, the reason why I don't use the scene spawner component here is because I want all these tutorials to be self-contained, so you can cherry pick them. If you only want to watch this video and not the scene spawner, then you can still make use of the example without relying on another component. But we essentially do the same thing. We instantiate it, update the global rotation and global position based on the muzzle where we want it to spawn the arrow, but we don't add it under the muzzle to the scene tree, but we use getTree.currentScene, which will be the velocity movement 2D, right? And then finally, we know that the arrow scene, we'll take a look at it in a second, it will have a velocity movement 2D component. So it's a bit of a spaghetti with these example codes, because I would never use something like this, like get node with the string notation and just rely on the naming of a scene tree. That's a horrible way to do this, but it's also a quick and dirty way to do this. And for these examples, I don't really want clean code. I just want working code to show you how easy it can be done. But it's a good exercise if you want to use it to make the code cleaner. Basically, what I do here is just say that the arrow should have a child node that is called velocity movement 2D, which is a velocity movement 2D component. And I set the gravity value to 980 if the toggle is currently toggled on. Otherwise, I leave it at 0. Do the same for the Boolean flag for the rotation based on the velocity. I just set it to true if the toggle is currently set to true. And that's about it. That's all we need here. But we also need the arrow scene. So if you take a look at it, the arrow scene export variable is set here. So let's take a look at how that works. But it's even simpler than the whole example scene setup. Now here we don't have spaghetti code because we don't have any code at all. And that's what's super cool about this. We have a node 2D base for this. It's called velocity movement 2D arrow. I didn't set anything on it. Then we have a sprite 2D child, which displays the arrow. We have a visible on-screen notifier 2D. And here I connected the signal through the editor, so I don't have to attach any code to it. So if you go to signals, you'll see that the screen exited signal is connected to the parent's Q3, but I'm not sure if it works because it says sprite 2D here. So let's just fix this real quick. Right click on it, disconnect, double click on it. And what we want to do is we want to select the parent node. When the screen exited signal gets called, we can just click on pick and filter for Q3. So we connect this node's Q3 method to the screen exited signal of the visible on-screen notifier 2D. And this way we don't have to add the code to the parent, we just do it from the editor, which some people don't really like that you can do this from the editor because it's kind of harder to tell. I tend to agree, so I usually connect my signals from code, but for this example, I think it works really well to demonstrate that now we don't need any code for this projectile to work. One thing that you can use to check on this is that when you connect the signal from the editor, this icon will appear. And if you click on it, it activates this panel. So if I go back to inspector and click on it, it switches and I can check on the connections. And we also need to set the velocity movement 2D component. So if we go to our inspector here, you'll see that two variables are set. One is for the speed, which I set to 800, and one is for the target, which is set to velocity movement 2D arrow, which is the parent of this velocity movement 2D component. For the gravity and rotation, I leave them at their default values because we change them when it's needed based on the toggle on the other scene. So that's a perfectly fine setup. I'll press Ctrl S to save this because I fixed that Q3 issue. And if we go back to the example and run the scene, you can see that I can aim with my mouse, and with the gravity turned off, I can spawn arrows that fly towards the direction I'm currently aiming at. But as long as it's spawned independently from the weapon, it doesn't matter that I still rotate the bow around. The arrows are independent. And we can check on the remote scene tree to make sure that they are deleted, and they are, because there are no arrows here. And if you turn on gravity, you'll see that the Y velocity gets applied and the rotation will be applied to the arrows as well, which looks pretty cool. If I shoot up, the arrows will eventually rotate around and fall down. Pretty cool, huh? And still, they are deleted automatically when they leave the screen because of the visible on-screen notifier 2D. Awesome stuff. Now that is mostly used for projectile movement, I think, in 2D games. It's super useful, like bullets or lasers, but you can use it with this arced version if you apply the gravity, which makes for a bunch of cool interactions. And also you can change that gravity value over time, like you can use the tween to animate it if you want something more unique. And it's just a component that you can always slap on things. And you can see that if it's set up properly, creating projectiles is very easy in games, and most times if you have all the components that you need, you don't even need to attach code to them, which is super useful and saves a lot of time. Now that wraps up the velocity movement 2D component. That's it for this video, and I'll see you in the next one. Bye bye.